Hello and welcome to another Hackers Challenge. Today we start another round of Andy versus Claude Code. So far it's 1-0 for Claude Code. But today I might manage to be smarter or not. We will see. I'm gonna let Claude write me another Solana program, but it's gonna be one of the difficult ones. Cause I'm gonna demand that it does randomness on chain. We'll see how it attempts to do that. And who knows, maybe Claude gets it right first time, there are no bugs in the program and it's all super good and we can't learn anything. Well, then I'm not gonna make this video. If you're seeing this, then Claude messed up somewhere. If there's nothing to learn in this video, trust me, I wouldn't publish this video. So the fact that you're seeing this means that there is something to learn in here. I promise. And also it's always just fun to get another Hackers Challenge. Because that's just one of the most fun things for me to do. Have a Solana program and attempt to exploit it. So I'm gonna let you do that again today. And such that we have a program to exploit, we're gonna let Claude write a coin flip program. You know, those classic casino style programs where there's a coin flip, like a 50-50 chance that you either double the sol or lose it all. Something like that. And the difficulty with that is that there is no random on chain. So I'm really curious what Claude would come up with if I tell it that it should write that program. I mean, from my perspective, the ways to go about this is definitely to do two things. One, split it in two transactions. If it's one transaction, it's easily exploitable. There must be one transaction to submit. And then there must be, and that's the second thing, any kind of an oracle or something that cannot be tampered with, or like an off-chain decision that is made that defines the result. And then if you win, you can take the payout. But let's see how smart Claude is if I tell it to write me a coin flip program. And you know what? Let's make this an Anchor v2 program. Let's go. I define it should be that. Okay, here we go. Let's be nice. Okay, so basically I'm saying create a coin flip program where you can bet 0.1 to 10 sol, and we're gonna have it a bit rigged. 49% will let them win and 51% will let them lose because we want to make money with this. If they don't manage to drain us, which I specifically said that it shouldn't be possible. So we will see. That's a tough one. I'm not gonna give you any more. Here you go. Enjoy your challenge, Mr. Claude. Well, I go and get a drink, because this is gonna take a while, I assume. Meanwhile, Solana randomness service uses switchboard. Oh, it said something. Check program directory and existing memory. No memory MD. Anchor version. I do have another version though. Yes, but you will find that in the cargo toml anyway. That I want Anchor in version 2. That's another challenge. Use Anchor v2. There's not that many docs on it yet. Or maybe I'm just making it difficult for myself because you will come up with bugs and I will need to fix them myself. The real challenge is the randomness and the setting up transactions in a way that I can't exploit the program. We'll see if it manages. I kind of think it will, but we'll see. We'll see. It's certainly doing something. Yeah, doing. That's what I said. It's doing something. I'm wondering what it's gonna do. I'm really curious. Keep doing. Let's go. Addresses as ref. Address implements. Now I have all the information that I need to write the program. Great! Then write me that program. Okay. Wow, it came up with to-dos. That's great. So we're gonna update cargo toml to add Pinocchio's system. It wants to do a system program transfer, which makes perfect sense. It even puts the things in the right files and everything. It's so smart. Yeah. Write flip instruction and randomness with randomness and payouts. Ooh. Randomness and payouts. Payouts seem to be separate. Build and verify. Okay, let's go. We added this dependency. Check. So we have a treasury in state with an admin, total flips, total wagered, and a nonce. An error. Yeah, right error as well. We have bet too small, bet too large, invalid choice, insufficient treasury funds, unauthorized, arithmetic overflow, withdrawal too large. Constants, treasury, so it seems to do a treasury PDA, treasury space, and then the initialize, admin and treasury, just initializes it with 0. Now comes the interesting part. Write a flip instruction with randomness and payouts. One instruction with randomness and payouts, we'll see. Yeah, go ahead. There's a fund instruction. I wonder what that is. It probably splits the funding with the flipping with the withdrawal, and then there's a withdraw instruction. Yeah, smart as Claude, eh? And then we write instructions. Okay. No, fund just funds the treasury, and flip does it all in one instruction, it seems. Well, let's see. And withdraw also just withdraws from the treasury as the admin. Okay, so fund and withdraw is just treasury stuff. You want to build it now? I think I want to build it now, because I'm gonna use my anchor here to build. There we go, build. Let's see. Whoa, it managed to build. And I will also tell it, if you want to build, use... It's smart. Tell it what to do, it does that. Oh no, coin flip, what is that now? That's in testing. The program compiles cleanly, but they're all test files referencing delete counter. Let me update. Great, I'll let you update. Yes, let me run it first. I want to see. Yes. Okay, you can run it. Burning credits, here you go. Now it also cleans up the 3 warnings. Yeah, sure, clean up the 3 warnings. I have too many credits anyway. I'm just always adding this crate, which I don't get why it's doing that, but sure, get rid of the warnings. Wow, it builds without warning. I think we're done here. I think our program is done. Full build with exit code. And now, what's your conclusion? Are we done? Do you also want to test it? What's that good for? I mean, sure, let's do it. Why not? I'm more a commentator of what the AI tells me. Failed. Awesome. Who cares? Instruction tries to borrow reference for an account which is already borrowed. Well, I guess. Okay, yes. Test it and figure out that there's a problem. It's gotta work. Otherwise, there's nothing to hack. What is in your tests? What are you doing in your tests? Coin flip initialize to account methods. But this instruction doesn't seem to go through. The borrow conflict on the freshly initial treasury is a known Pinocchio issue. The simplest fix, remove initial funds from initialize. That's a known Pinocchio issue? We can't borrow the freshly initialized. What are we changing now? Okay, yeah, whatever. I trust you. Do it. Now update the test. Again, I have too many credits anyway, right? Initialize and fund. And we test again. And we fail again. This time with invalid instruction data. Damn it. I'm just gonna let it run until it has a working program. Oh yeah, we didn't anchor build. That is true. You are right. Smart Claude. And then if we build it, it still fails. With instruction tries to borrow reference to an account it already borrowed. So same thing as before, but now in the fund. Maybe I shouldn't have let it use the anchor v2, but just pure anchor or something that is less complicated, because I'm just burning through my credits now. I still need them for other things. Meanwhile, we can already look at the flip, because we can already see how we're gonna hack this while it's still fixing stuff. So we have a player, we use the treasury and system program. So as doing some checks, we have a choice that we bet on, and we bet the amount of Lamperts. Treasury must hold enough, otherwise we have insufficient treasury funds. And then we transfer from the player to the treasury. So far, so good. And then we snapshot entropy before updating state. Okay, we get the clock sysvar. The nonce is always taken from the treasury, and then update the treasury counters. And then we build a hash from multiple entropy sources to predict or manipulate the outcome cheaply. I like it. So the admin address, the player address, the Unix timestamp, the slot, and the nonce, all pseudo-random stuff. And then we build a hash from this, apparently. Yeah, we SHA-256 hash this. And then we take 1 byte and modulo 100 it. I mean, that's not even 100% then. This way I have a way... I mean, this is... I mean... yeah. So many things that is wrong with it. Like, so many things wrong with this. Because this is a 255 value, right? It's a byte. It's 0 to 255. The chance of a lower roll, like 0 to 55 is higher than the chance of a higher roll, 56 to 99, because this is a byte. It actually favors the player. It's even... Oh, this is so stupid. But anyway, that's not the biggest problem in this, I think. Stupid implementation. But we'll see if I get to exploit it. We'll see. I don't want to spoil. I'm not going to tell you. But I see issues with this. I want you to be able to exploit that as well. Okay, so we have roll, choice. Yeah. And the result side is always the thing that it didn't... I like it. Wait, 0 for heads, 1 for tails. If roll is less than 50... Wait, how does that make sense? The player wins if it's less than 40. And the result side, if it was that, then it's... So we switched the result side depending on what we rolled. Yeah, of course we do. I mean, that part is rigged. I told it that it should rig that, so that's fine. Okay, you're still working on something. I'll let you work. If player wins, we actually do a payout. We multiply that by 2 and then transfer from treasury to payer. It's owned by the program, so we can directly move the Lamperts. Yep, smart. And then account view is copy, set Lamperts rights through the raw pointer. Wow. Player wins and otherwise the house wins and we keep the Lamperts. Wow. Okay, so your initial implementation, we're gonna fix your bugs, but the initial implementation is full of exploitables. Like, this is so easily exploitable in so many ways that I'm gonna commit it for you to exploit it. Because it's just, we're gonna work on a better version, don't worry. But first we need to figure out how to fix those issues. Maybe I shouldn't have used Anchor v2, but whatever. Claude will figure it out. Claude is smart. Except when it comes to writing a conflict program, then you suck! I'm gonna get my point. This time I'm gonna be smarter. High confidence again. This time I'm very confident that I can hack this. Yeah, maybe I'm overconfident, but I'm very confident that we can hack this. So, yeah, check out the repository in the description. I will have committed this, and you'll get to hack version 1. Shouldn't be too difficult. In fact, should be super simple. Oh, we're already at 42% usage. We'll see how far we go with this, or if it even manages to. Let me stop trying to trace the internals and instead use invoke signed unchecked directly. It skips the borrow state check entirely. You change to Pinocchio with CPI, which is probably what you should do. Yeah. Again, I trust you. Do whatever you gotta do. What did you change? I have no idea. It does a system transfer now that we have in the utils where it does an invoke signed unchecked. I'm sure there's a cleaner way to do this, but hey, if that's your way of fixing it, fix it like that. Now you also here in the flip probably do the transfer with a system transfer, whatever. If you make it work like that, I'm happy. Because I'm just vibe coding here. I'm not gonna write the code myself. Not here. I'm just gonna write the code for hacking it. And I'm also gonna tell it, can you also write a quick test for the flip instruction? Does that even build currently? Yep. And the tests? Yep. Look, the tests come back. No problem. But I also want the flip to be tested. And then we start hacking. Verify that the treasury has enough cushion to pay out 2x the bet even before receiving the player's wager. So the house can never be drained. Wait, how does that, how does checking that we have enough money in the house make sure that the house can never be drained? What? What's that logic? I'm gonna outsmart you this time. I'm gonna drain that house. I'm gonna drain that house down. What are you still baking? What are you even doing? Clauding. It's Claude. Of course it's Clauding. Okay, stop it. Wait, we build. We test. Both come out okay, which means it should be fine to run those instructions. Okay, which means this is our final first version. So git add all of it and commit version 1 of vibecoded coin flip program. Hack this. Side note, this is not a program you should use. Should I write that in my commit message? Nah. Okay, and you will get to hack this as well. And that all just took me 50% of my pro plan in the current session and about 10% this week. That's okay. I could also do Rust for my hacking. Haven't done that in a while. Write a Rust script. But also, no, I think I'm gonna do the standard TypeScript that we're used to. Yeah. But even before that, step 1. We're gonna get a flip, because I love my vanity addresses. Flip. And we're gonna get a Claude. There's no L, but that's a letter too much, I think, especially with the L. Clock, almost. And then a hecken. Heck now, why not? Okay, copy, flip to target, deploy, key pair. We could do the anchor sync keys or whatever it was, or we manually paste that here and here. We're gonna go defnet and we're gonna use this. Okay, both start with 5 sol. Okay, we rebuild and deploy. Oh no, use anchor program deploy. It's not deploy anymore, it's program deploy. But also, oh, I didn't save that file, that's why. Flip, what could possibly go wrong? Just for fun. There's one more thing that I want Claude to do though. Please explain to me while this is safe. And maybe it will realize that it's not safe. But maybe it will explain something to me because it came up with that. Let's see what it does. If I prompt it like that, we'll see. Yeah, please read through your own code carefully before you give me an answer. Okay, oh, there's a fix, so maybe it's not safe. Okay, let's check. Here's the honest breakdown. The house is never put into a position where it owns money it doesn't have. You can't own money you don't have because the transaction would fail anyway. This is just stupid, but okay, I take it. Arithmetic overflow protection. Very smart, okay, yeah. Correct Lampert accounting. And bet bounds are enforced. But then it's also not safe, but I don't think I want to look at that yet. I don't think I want to look at that yet, because that's spoilers. One real weakness. One? I'm peeking again, but one, there's like 200. No, they're at 3. And the fix would be a commit reveal scheme or an on-chain function like switchboard. For a demo program, this is acceptable. A production real money, you want one of these. The vulnerability is the predictable randomness. Someone who can simulate the hash can cherry pick winning flips. Yes, that is certainly one thing that is an issue, but it's by far not the biggest one. Because even without, you know what? Fair enough. I'm willing to pretend that this is real randomness and you're getting a real hash. I'm not gonna even attempt to cherry pick on your randomness and I'm still gonna hack it. No problem whatsoever. Okay, but other than the randomness, this is safe, right? I keep probing it. Keep probing. Yes, other than the randomness, the fund security is solid. Okay. I take you up on that. It's 1-0 for you. You're in the lead anyway. And I need a point for my cracked self-worth or something. The only real attack surface is the predictable randomness. Everything else is correct. Well, what about... And we're gonna get to this later. Let's first hack this. We deployed. I am gonna borrow the Kodama creation script. Let's run this. Oh, generated. Wonderful. So we have source generated, of course. I don't know why it does that twice. Maybe because I'm putting source generated here and the render visitor will also put source generated maybe. Yeah. So this renderer visitor already has the source generated apparently. Anyhow, with this generated stuff, we have the initialize and the fund and the flip and all the instructions as helpers. We just need to import some things as well, like this stuff. And then we can write a script. First, we're gonna just write the script that properly initializes it because we do need a treasury. Such that we can exploit the treasury. New file, create and fund treasury. What we are going to do, that's gonna be the proper key pair. Clock has the funds that we're gonna put into this. Gonna work on DevNet. And what we're gonna do is import from the generated stuff. We're gonna import a get initialize instruction that will have the admin, the treasurer, and the system program. So admin, I can also call you admin. You gonna be my admin address. Well, actually, do I need to sign? Yep, nope, I'm gonna provide the admin. And the treasury, isn't there also a... No, you don't. Okay, so then we need to get, if I want the PDA for this, find treasury PDA, there, that's what I want. Ha! And you need the program address. I have that. Because also that will be in here. Coin flip program address. Cool, then I get the PDA. Treasury PDA is this. Let's go. So I can put the treasury here And the system program, it should find itself, so that should be fine. So we just initialize this, and then we need to fund it. So we get a fund instruction, and that also needs the funder, which will be my admin. The amount, which will be, I don't know, how much do we still have? Let's quickly check. I should still have like 4 sol or something. Yeah, 4.6. And even if I put 4 on there, I have enough to rebuild the program. So that's fine. I can put 4 on there. So let's put 4 sol, and the treasury is the treasury again. Cool. That should fund the treasury. Let's just see if that works. Create and fund treasury. And yeah, look, it just works. We created a treasury that now has 4 sol, but not for long. I'm gonna tell you, Claude, I'm gonna hack this. Not even exploiting your stupid randomness, which by the way is stupid, but we're gonna hack it anyway. Let's start with a normal play. We are gonna play as the hacker, and we're gonna get a flip instruction, and player is the hacker, and we're gonna bet 1 sol, and we're gonna bet on, it does not matter. We bet on tails or heads, whatever 1 is, because really it doesn't matter what that is anyway. The chance is calculated on the, yeah, you know, you've seen the source code. But this is just to make the impression to the user that he has choice, which he doesn't. And the treasury shall be the treasury. Okay, good. That's a normal play. And then let's see the starting balance. RPC, can I get balance for the hacker address? And I'll get the value right away. And I have Lambert's here. And then we do the same after we send the transaction. Final balance. Let's just log this. 1E9N, no? A big int literal cannot use exponential notation. You're annoying. Nah, okay, fine. Okay, let's just play. So we play. What could possibly go wrong? Huh? Look, what? That we don't win anything? This is also not doing the thing that I expected it to do. Oh yeah, sorry, we're in TypeScript. I forgot. I'm still gonna check this transaction. Maybe I was just too quick for the RPC to get the update. It looks like we as the hacker won. We were apparently just lucky, right? And Treasury lost 1 sol because we flipped tails. And look, we rolled 42 and the player wins. So player payout. Yay! Nice. We've won 1 sol. That went well. We were just lucky, right? Let's play again. Hold on. Can I give you a config for commitment processed? Because I want the most current. Yeah. Let's play. Oh, look. We won again. What a coincidence. I mean, no, we were just lucky twice. If you flip a coin twice, then yeah, that's not so unlikely that you win twice. We're gonna lose once now. Oh no, we won again! Oh no, the treasury is getting slowly drained. But okay, 3 times winning, that's still possible in a fair coin flip, right? I think the treasury can afford 1 more time. No, it can't. Custom program error 6003. Okay, what's the error? Insufficient treasury funds. Yeah, looks like my treasury is drained. Yep, I can't pay out. There's still a logic error. I can still not pay out the 2 sol because there's only 1 in the treasury. So that's how it can't ever fully get drained. Maybe that's what Claude meant when it argued, oh, it can't be drained. Anyway, well, fine, says the hacker. Then I just bet half a sol. And we play again. 7-7. Who won this time? Yeah, finally! I almost thought this game was rigged. Because it is. But yeah, finally the treasury won once and it's back to 1.5. Great. Let's play one more time. Oh, we lost again! Great. This is a fair game, right? Now we start losing. Treasury is picking up speed. It's got 2 sol now. So we can play for 1 sol again. And then it's gonna lose again and whatever. Look, we won this time. And now it doesn't have enough funds again. So, what's my point? My point is, I don't even have to do anything else than do the regular thing to exploit that program because there's a bug in the business logic. Claude, you made a mistake. in your business logic. You're giving the player a much higher chance of winning than I told you to. And the issue is here in this line. You're calculating the roll with a modulo 100 because you want a value from 0 to 99. But maybe you should have gotten a bigger number here than a 1 byte. That is 255 at most, which will, of course, prefer the lower numbers. And if you make the low numbers the player win. If you did it the other way around, then yeah, it would just be difficult for the player. But this way, a normal roll will drain the house. And the house will win in 1/3 of the cases instead of 51% of the cases. So this is just like, come on. I would have expected better of you, Claude. Honestly, but yeah, I mean, to really demonstrate this, let's drain slowly. Let's just play several times with 0.1 sol, the minimum that I can play. I'm just gonna while through this. And also, let's count the wins and the fails. Coding manually, isn't it nice? Okay, also every 10 times I'm gonna refresh the block hash. And then I should do some waiting somewhere, maybe here. Let's do every second. If I would do local, then I could run it faster, but I'm testing with DevNet for whatever reason. So I'll be rate limited. That's just to prove a point. And that is that this game is rigged already for the player, which is stupid. But let's drain it slowly. Let's see what happens. First transaction, we win. Oh no. And then transaction simulation failed. This transaction has already been processed. Oh, because we are not changing the block hash or anything, and we're doing the exact same thing. Okay, so I need to get some entropy into here. I don't know. Get a transfer sol instruction and transfer from the hacker to the hacker I Lamperts. There you go, whatever. Just so it's a different transaction. Okay, let's run this again. Drain it slowly. Look at this. We won again, and then we failed once, and then, oh, we failed twice, and then we failed 3 times. Oh no, maybe this does not work. Maybe Claude was correct after all. No, give it time. I'm fairly certain that I will win with this strategy. It still looks fair. Look, 5-5, but on the long run, I think I'm gonna win with this. Just saying. I'm just slowly draining the treasury. Slowly draining. That's how you do. That's how I love it. Oh, 10-10. Maybe this game isn't rigged. I'm failing again. Wow. 12-12. Maybe it's not rigged after all. I will need more than 100 tries though. 17-17. 18-18. Maybe Claude once again outsmarted me. I'm a bit ahead now. But not as far as I would imagine. 24-18. 30-20. This is the ratio I would expect. Is it though? No, the actual ratio I would expect is... Oh no, we died. Because we drained the treasury? What was the last transaction? So it's 32-20. Wow, in the end we kept winning. You just need to have enough capital and you can drain it. Yep. Look, at that point the treasury is just entirely drained. Except for the 0.1 that is still on that I can't get off because there is this protection. I can't get that. But as much as you can drain, I drained. Because the treasury needs to have as much as you can get out in the end already before. So there will always be at least that amount in there. But I consider that drained. Yeah. And so we ended up with 32 wins over 20 fails. Wow, in the end we really just kept winning. And maybe that's because the hash is also not super random. Wait, what does it depend on? Where's my flip? Here. So, it depends on the admin address, which we know, the player address, which we know, the Unix timestamp, which this one is the hardest one to predict, but it's also just seconds, so it's not impossible to predict this. And also, you could just write yourself your own program and call the flip from the program with the CPI, and then you know this. Then you know the exact timestamp and you know the exact slot. Although the slot is also somewhat predictable. And the nonce, well, that's just taken from the treasury account. Yeah, theoretically we know all of those things and we could take a favorable time when we would know that we win. But we don't even need to do this to exploit this program. That's the funny part. Even if that was solid random, which it isn't, this still screws it. Like so hard. Oh, Claude. You poor bastard. Even if I would fund the treasury, because I'm a kind hacker, and I Solana transfer to this address. Wait, how rich am I now? 8 sol, 8.8. I need a little bit of starting capital, so I'm gonna give you 8 sol, because I'm so confident that I will get it back. And I'll send from the hacker. There you go. So the treasury should now be funded again. Look at this. Got 8 sol. Yeah. And now I'm gonna drain it slowly again. Drain slowly. But we're gonna do 1,000 runs, because that seemed to have worked pretty well. And then also, because I'm interested in it, I want to know the exact ratio. Hold on. Before we do that, I also want to print the ratio. Let's do wins over fails, but in float. In my head, the ratio will be something like 3 to 2, which is a ratio of 1.5. Ratio of 1.5 when I said it. But it's still too early. We're still, oh, now we're back to a ratio of 1. Oh, we're even losing now. But we'll come back. We'll come back. Don't you worry. This will come back. I still have 0.8. I'm good. I will be coming back with this. Fun times. And the actual ratio, let's ask another AI, because I'm lazy. And I'm sure that Claude could answer me that as well. But I'm not asking Claude, I'm asking the chat now. Yeah, I don't need the explanation. Just give me the final ratio is 174 to 109, which comes down as... That's actually not so bad. The player still wins 57% of the time. I thought it would be higher. So 174 by 109 is actually 1.3 as the final ratio. I said 1.5. Yeah, okay. Because we are getting a little bit with this. We're swaying it a little bit towards losing with this. And yeah. Okay, cool. But nonetheless, in the end, we should be making money with just playing this game consistently. And we are. Look, I'm already at almost 2 sol. I'm at 2 sol. I'm 50-40, which is a ratio of 1.25, which is roughly what we expect. So I think at that point you can believe me that this strategy alone, like not even doing anything with transactions or anything, and I'm still winning. I'm still draining the treasury literally by just playing that game. How stupid can you be, Claude? Sorry. But for real, I mean, come on. It's okay to make mistakes and stuff, right? But like, dude, that's like so bad. And that's just the first level of what I can do. Just playing that game and exploiting your business logic. I think that's a point for me, huh? Would you agree? I think it's a point for me. I'm just gonna take that. I'm gonna gladly take that point. My point. Thank you. It's 1-1, Claude, now. We're in a draw, but I'm not done. I'm gonna prove you wrong one more time in this video, because you confidently said that the only real attack surface is the predictable randomness, which is just also so wrong. Ooh, we're 1.3, 1.31, 1.33. That's pretty much what we expect, no? What did we say we expect? 1.348. The longer we let it run, the closer we get to the number that ultimately is what we expect. Of course, there's still some luck in there, and currently Claude is being lucky that we're failing a bunch of times. But overall, I'm still winning. We're still over 1, and if I let that run for infinity, then we will get to exactly that percentage. I mean, we're still paying for transaction fees. You also gotta calculate that, but I can send a lot of transactions for that price, and I'm still winning. Even accounting for that, I'm still winning with this. How long am I gonna still let that run? Until I'm done with my next exploit. So let's move on, because that's just the first bug that I'm exploiting. There is certainly a bigger issue with this. As I already said in the beginning, if you're doing a coin flip, not only is it important that you have reliable randomness, which this is not, but I give you that. You said that this is not, so fair, Claude, fair. Even if that was real good randomness with a switchboard oracle or whatever, I can still exploit that on a transaction level. Like so easily, because it's all done in one transaction. And guess what? If you paid attention to my previous videos, this one for instance, then you know that transactions are atomic. Or actually, if you've done anything on Solana, you should know that transactions are atomic. And therefore, if another instruction fails my transaction, this will not be persisted. So you should never do the deposit of the bet and the payout in the same transaction. Just don't. No, you can't do that. Coin flip program 101. If you do that, you're gonna get drained. Let me show you. Let's do a drain quickly. Because all I need to do is first of all know how much money is in the treasury. This time we're gonna drain the entire treasury in one go. So I want to know how much is in the treasury. Treasury balance is this. And then we gotta bet half of that minus rent. We have the treasury size. Get treasury size. That's one of the convenient methods that we have in the generated code. It's 64, but this needs to be a big number. Pain of my existence, as I mentioned several times before. So that's the rent, and our bet will be the treasury balance minus treasury rent. And then we can just do half of it. Yeah, this is a stupid rule that you implemented there, Claude, that at the flip you're checking that available treasury lamperts minus rent is what's available, and you must have twice the bet lamperts available. That logic is stupid, but okay, yeah. So we can't fully drain it, but we can still always half drain it. Fine. And then I could do the same with like half the size and get smaller and then also get to that. But you know, so it's definitely quicker than this. By the way, are we losing here again? This is getting worse, that ratio, but we're still winning. Anyway, back to our drain. So the bet is this in half. There will not be fails, so I don't need to track this. I'm gonna just run it once. Okay, wait. The bet amount was here. Okay, now, maybe this is already a hint. So, the idea now is that if the outcome is inconvenient for us, then we just make the transaction fail. Easy as that. And I could use a custom program for that, or I could use Lighthouse, or I just use a simple system program transfer. And what am I gonna transfer and where am I gonna transfer is the question. I know my starting balance. I'm just gonna transfer my starting balance from myself to myself, because if I have less than my starting balance, then I can't transfer my starting balance. Even if that really does nothing. I mean, I transferred to myself, but the system program still checks that I have enough funds to perform that transfer. So, this is basically just a check if the lamperts in my account are bigger than or equal to my starting balance. You see where I'm going with this? This protects me. I can literally not lose with this. I mean, the transaction can fail, yes, but then worst case, I lose transaction fees. And I don't care about transaction fees. It's gonna be fine. Okay, but for that to work reliably and not be messed up with this stuff, I'm gonna kill this now. You see that I do manage to slowly drain it. Even if it's not quite the ratio of 1.3 something. If you round up, it's 1.3. It still clearly favors the player winning over the house making money. So that's just a logic mistake that you made, Claude. Nothing personal. I just want to be smarter than you for once, okay? If I would tell you to fix your business logic, you would of course find that error, right? Like, what about, is the house really winning 51% of the time? It doesn't seem like it. No, this is a real bug. Look at the roll calculation. I told you. It's not like I didn't tell you. Now I told you. Well, now I made you find out. I told you guys behind the screen. Hi, it's me, the guy who wants to feel smart by making an AI write bad code and then pretending that he's smarter or something like that. Yeah. See, you explained that, and then you can also calculate that, and you find out, as Chat also told me, that you're actually losing 57% of the time. The house is losing money on every flip. Yeah, the player has an edge instead of the house having the edge. Fix user U64. That should then be neglected. Blah, 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 blah. Yeah, that's a great idea. How about, please implement this fix. I don't want to do that myself. Come on. Copying one line of code, way too difficult. So yeah, we now calculate the roll with a proper U64 from that hash. That seems more reliable. This change, the house now generally wins 51% of the time. Not like in the old version, where I'm already back to 8 sol again. Look, I'm winning. So winning. Okay, but you fixed this. Okay, fine. Let me quickly check. Fixed chances. House not losing anymore. Maybe I should have first checked that that actually builds. It does. Good. Okay. I mean, soon we're back. Soon we're back. I'm gonna let it finish now. It's not long until treasury is drained. Treasury is already down to 0.6 sol. This is so fun. I love hacking. In case you can't tell, I love hacking. There we go. We reached the point of the treasury being empty. And by empty, I mean 0.1. That's still the, a stupid rule that you have there. Okay, so in the end, we've won 340 and lost 261, which is a ratio of 1.3, which is what we expected. We expected, roughly this. So yeah, we can slowly drain the treasury like this. But not for long anymore, because Claude came up with a fix that we're now gonna deploy. All right, fix it. All right, so except for the randomness, is it safe now? Yes, with this fix in place, house has the edge, treasury can't be drained. I still don't get the 2x pre-check. You can't be fully drained, but you can be drained up until the point of 0.1 sol. This is just stupid rule you have there, but okay. I will still come back to this with, well, but what about, in a second. First, let's prove to you that even though we can't drain it slowly anymore, even if we send 8 sol, nah, I'm not gonna send you 8, I need some capital. I'm gonna give you half, I'm gonna give you 4. If I would now drain slowly, now it would be 50-50, or actually I would be losing in the long run. So I'm not gonna run this for long. In the long run, this will come down to a ratio of 1, or actually 0.9 something. Yeah, we're back to 1, 0.8, 1. So it will now, I mean, I guess you believe me, right? With that fix, the flip actually takes a U64 and then does modulo 100. That way, it's fairly fair game. Well, unfair game, really. But at least this is an actual random number between 0 and 99, not like it was before. So yeah, we expect something like this, or even this. Yeah. So I'm gonna kill it here. It's good enough, thank you for demonstrating this. I cannot use this strategy anymore of just playing to win. So we need to actually do a drain, and we're gonna do a drain quickly with this strategy of just protecting ourselves from losses. It's not like we're not playing, it's just that we're protecting ourselves from losses. So let's go. Let's drain quickly. Let's also see this. I want to see how much I bet. Let's go. We are betting. Whoop. Wait, what's that error? You don't have enough funds? I thought I calculated that. We're betting 2.3 sol. Your treasury has 4.3 sol. Wait, what am I doing wrong? Half of 4.3 is not 2.3. There is something messed up here. That's Lampert's. That's Lampert's. Oh, the treasury balance I should of course get from the treasury. That's my issue. I was checking my own balance instead. Okay, with that quick little fix. Also, by the way, no, I'm gonna show you this. We have a 50-50 chance that the simulation already fails. Yep, that's what I expected. There we go. Transaction simulation failed because we have insufficient Lamperts when we're doing the system program transfer. We have that many and we need that many because it seems like we lost in the simulation. Now, the simulation doesn't know shit about, the real world because we might be in another slot. So to not have to bother with this simulation, I'm just gonna send the transaction with skipping pre-flight. So no simulation before, we just send it. And then it's gonna fail on chain if we're unlucky, but at least the script doesn't stop if the simulation kills us. So let's do that again and see if we're lucky this time. We did send and we were lucky this time. Look, I love this so much. So we bet 2.15 sol and we got 2.15 sol, and our protection with the system program transfer that sent 4.6 sol to ourselves really doesn't have an effect if we have 4.6 sol on our account, which we have because we won. If we would have lost, that thing would have failed and saved us. And that way we can quickly drain the treasury, because now it's 2 sol less, so it's now down to 115. We can keep playing that game, drain it one more time. This time, oh, we actually lost. Oh no. Custom program error. That's instruction 2 is the system program, and custom program error 1 is the 0x1. That's the insufficient balance. So now not the simulation failed, but when we're trying to confirm the transaction, because here we're also confirming the transaction, we are getting that info that yes, the transaction is confirmed, but it wasn't successful. That's why there's errors, which, you know, fair, we just failed. But all we lost is the transaction fee. So I don't give a fuck about that. The treasury still didn't get the funds that I bet, because I did bet those funds in the flip. I did bet those Lamperts. I did bet 1 sol, but I lost. And then this guy saved me. Okay, let me quickly change my script a bit. Let's just try. I could also just send and not confirm. We lost, but that's okay. Let's do it again. This time, oh, we lost again, but we're not losing much because we still have the same amount in the end that we have before. Just the transaction fee is what we lost. And one more time, we lost. And one more time, we won! Yeah! Once we won. Nice. So again, you gotta run this a few times. I could also do a loop in my script. We always have to bet half, and then until we get down to 0.1, until we reach the limit. Now we're already at the lowest possible thing we can bet. We won again. And now we are below the minimum. So now we will always be losing, but now it's not because of our protection that we're losing. It's because this instruction is already failing, because it's failing with 0x1770. And anchor in v2 is being efficient, and it's not logging the actual error, but the actual error is the 0, so the first one, bet too small. That's this one. Yeah, and that way we can more quickly drain that program. So I would say, with the treasury being empty again and the hacker having all the funds again, I think that's another point for me, no? What you say, audience? Do I deserve a point? I don't know. Do I deserve another point? Doesn't matter. No, it does matter to me. I take that point. 2-0 for me, damn it. Because what about transaction level attacks? What about them, Claude? What about transaction level attacks? I think I win. I made another fair point. I think it's 2-1. I think I'm going to stop now. I'm going to stop when I'm in the lead. And we did well. If you understand, if you could follow so far, then great. We're doing good in hacking Solana programs that Claude wrote. Not to bash Claude Code or anything. This thing is doing a great job. But it's not perfect. That's my whole point. It does make mistakes. Because in previous videos it seemed like, oh, it gets everything right, it's even smarter than me. That's why I wanted to make another video proving that it might not be so smart after all. Or at least not so perfect. Okay, 2 attacks, both stemming from the randomness issue, but at the transaction level. Selective submission, all inputs to the hash. I don't need to know shit about the inputs of the hash. You can have a perfectly fine hash. A player simulates the SHA off-chain and only submits when... Yeah, this is actually not even that big of a deal. But this one is. Abort if lose, the more dangerous one. Yeah. A player writes a wrapper program or uses the system program because they're smart. Like us. CPI into the flip, checks if the sol balance is higher. If balance went up, keep the winnings. If balance went down, abort with error. Easy. Yeah. So you understand that this is an issue. Great. Good job. Both attacks have the same root cause. The outcome is determined inside the same transactions. That settles the bet. The only fix is a 2-transaction commit reveal or an on-chain very random. Not or, whether the randomness is committed before the player can act on it. But that the payment still must be taken before we analyze. Because even with on-chain randomness, the randomness is not the problem. In this case, the randomness really is not the problem. It's that we have one transaction for payment and payout. That's the problem. So how would we implement a fix for this? Commit reveal. Transaction 1, commit. Player picks a secret random variable, submits and their bet amount. Bet is immediately transferred to treasury. No abort possible. That's the important part. And the player stores the commitment, bet amount, the commit slot, and the reveal must come at least one slot later. Yeah, good strategy. The player reveals are, the program verifies, and payouts are kept, and the PDA is closed. Outcome mixes in commit slot, which the player doesn't know when choosing R and therefore can't predict. That I disagree with, because you do know what slot you committed. You can know what slot you committed. Player knows R but not the future slot. House knows slot but not R. Neither can manipulate alone. Well, no, player would also know. In fact, edge case, player commits, then ghosts, never reveals. The house can call a settle expired. That treats non-reveals as a loss. I mean, it's a fair implementation. It plays for the house, I'll take it, because you can't ghost me. But that's good that you're also coming up with that edge case, because otherwise, of course, I mean, if the bet amount was already transferred, then also I don't really care if they're bound to lose anyway. Or option B, and that I don't think is actually safe. Player submits a flip request, bet gets locked. Off-chain oracle generates randomness. Post it on chain. Program verifies the proof, settles the bet. Okay, so we still have 2 transactions then at least. Process a single player transaction, cleaner UX, and randomness is provably unbiased. Cons we have an oracle dependency, fees for that, more latency, and it's more complex to integrate. Cool. Let's implement option A. Here we go. Here we go. It's reading the current program such that it can do the correct changes. Great, let's go. Yes, we need to add some errors. Let's go. Add something to the state. Let's go. So we have a pending bet. Nice. Pair, commitment, commit slot, nonce at commit, bet Lamperts. So it even takes the nonce at the commit time. Yeah, that's right, the commit file. So in the commit, we are basically checking treasury funds. Okay, still checking treasury funds, and then we're doing the system program transfer and writing all of that stuff into the bet. What does settle expired do? That should basically just close the PDA. Doesn't do anything, no? Okay, let's see. The new flow. Commit, wait one slot, reveal. Player submits and reveal. Closes the account. Bet stays in treasury. So really it just closes the bet account. This doesn't do anything else. That's the interesting part here. The close, which is closing that pending bet that it's not open. But the funds are in the treasury anyway. Okay, so you can't wait for better times when it's convenient for you. Good. And then at the actual reveal, we are checking that the client seed is actually what he committed as a hash earlier. Yes. Checking the times. Why is this still up here? Is that not done in the commit? Okay, I would have done that here, but whatever. So this is the interesting part. The entropy sources is the client seed. So the client has some say in what gets in here. The admin address, which is fixed. The commit slot, which the player can also kind of choose, and also the nonce, which can also kind of see. So in my eyes, this is still definitely hackable, but I'll leave that as homework for you. Also, Claude, yeah. So is this safe to use now, or is the randomness still a problem? Yeah, you're thinking. I hear you thinking. I see you thinking. The commit reveal design fixes both attacks. Abort if lose is fully defeated. Outcome prediction also defeated. So Claude seems confident that we cannot hack this anymore, because the outcome depends on the SHA of all of this junk, and the player picks this chunk before submitting the commit, and commit slot is whichever slot their transaction lands in. I still think this is a bad assumption that you have here, Claude. This is still not at all safe, because not only could you again still do an abort if lose if the commitment slot is not what you anticipated, but also you can predict the commitment slot pretty well. I mean, 400 milliseconds is really not that bad. Besides, do a CPI and you know which slot you're in. So easy. And what about only revealing when you won? This doesn't help. Bet is already in the treasury anyway. Yeah, that's fine. One remaining theoretical concern. Oh, a validator. A validator who controls which slot a transaction lands in could be... Come on, Claude. I don't need another point. I don't need to win 3-1. I'm perfectly fine with the 2 points I have, but I leave this for you as homework. You can still hack this. I am fairly certain. I'm just not gonna do it for you. Or I will, but it's not gonna be part of this video, because I still want you to figure stuff out yourself. Get your hands dirty and shit. Short answer, yes, it's safe for practical use. The house edge is real. No, it's not. You're imagining things, Claude. You're imagining things. You are a great programmer. I give you that. I would have not managed to write that program that quickly. But also, it has severe security issues. So, yeah, would not recommend actually using it in production. But I'll let you be the judge of that. And I'm gonna commit this. Have fun. I shall push this to GitHub and let you have the source so you can play with it. Oh, also, first of all, we should have done that before. Does this even build? No, it does not. Should have checked this before I commit. Sorry. But that's just in tests. Yeah, whatever. Screw the tests. Good. Gonna end it here. So, do you take on the challenge of trying to hack this version as well? Claude says it's safe. I say it's not. Who do you trust? What do you think? Again, I've been wrong before. But that's why I had to make this video. To showcase that even though those LLMs, they are great in coding. Claude Code is such a helpful tool when you're doing some programming, but you can't blindly trust it. That's my main message of this video. You need to still think yourself. And even if it tells you that it's secure, it might not be. Claude also makes mistakes, and so do all the models. So use them with a grain of salt. Use them as an assistant rather than the main programmer. That's my personal recommendation. But yeah, you do what you do. I just want to showcase that today I had a very easy time exploiting the code he wrote. Like, that was like almost too easy for me. Like, it was almost predictable that I can do those things. I mean, fair enough, I chose a difficult thing. So yeah, I did that on purpose. I led you on, Claude. But it's for a good reason, to make a point. And the point being, just because we have AI now doesn't mean that we can stop thinking or not do security audits or let AI do the security audits. Because, yeah, at least with those models, it's not there yet. It's not there yet. It might be one day, but not today. Alright, I'll leave you with some other hacker challenges. Like this video if you enjoyed it. Subscribe if you haven't done that already. And I will see you in the next one. And until then, you have my coin flip program to hack in 3 different versions. Enjoy.